Yeah, thank you, Akash. Okay, so let's just start our discussion. Have you watched that earlier lecture which I have just uploaded? Okay, great. Cool. So in that lecture, I have discussed just one question, I think, this question number 2. So that lecture was related to basically just to tell you that you can work with the function of random variable. So there we have defined some function of a random variable, which is a random variable itself. And now we have solved this particular question and one variation of it with, different methods. So I hope you have understood that, right? If there is any doubt, then please let me know. Okay, even if you have not watched that particular lecture, then also it is fine. Like we will be continuing with the new examples. Okay. So hi Gaurav, good evening. Yeah. So we have used couple of methods. I mean, all the methods are actually boiling down to the same thing. But yeah, anyway, there were a couple of methods. Cool. Where was that lecture uploaded? That is on the website only. Now let's just solve this particular question. So here, what they are saying, consider two random variable x and y with joint probability distribution given in this table. Now, do you remember there was one question? Okay, Twinkle is saying एक क्वेश्चन अगले एपिसोड में डिस्कस करेंगे यहाँ पे एपिसोड तो नहीं है, लेक्चर ही है. Okay, so do you remember there was one question which we were discussing related to, I think then there was one gate PYQ which we were discussing, and then it was having a high temperature of Delhi, high temperature of Guwahati or something like that, right? So in that particular question also they have given one table, but I think that table was representing conditional probabilities, right? I mean, they were saying that okay, this is the probability that Delhi temperature is high, given that some like Guwahati temperature is low or something like that, right? So the table was representing the conditional probability. Do you remember that? Now here they have given a table, but this table is representing the joint probabilities, which means this table is saying that this is the probability, this is the probability of y being 0 and at the same time x being 0. Okay, this is the probability of y being 0 at the same time x being 0. So this is what this table is saying. So I hope that is the notations are fine, right? Which means like it is not necessary that whenever table is given, then you will say that okay, these are the conditional probabilities. No, they will define it, right? Now in this question they are saying that probabilities are joint probabilities. Cool. Now they've asked couple of the questions. So given the joint probability distribution, they have asked couple of the questions. Just tell me what is the probability that x being 0 and y being 1? This is very obvious from this table, which is x being 0 and y being 1 is 1 by 4. Okay. Now, what is the probability that x being 0 and y less than or equal to 1? X being 0 and y less than or equal to 1, it means you need to add both of these probabilities, right? 1 by 6 plus 1 by 4. You don't need to calculate it, but you can just tell me final answer, which is 5 upon 12. Okay. Which marginalization? Here you don't need marginalization, like command is a joint probability distribution is given. So I think that is fine, right? Okay. What is the probability that x being 0? What is the probability that x being 0? Acha, for this particular question, you are saying marginalization. Yeah, you can say it. Yes. So what is the probability x being 0? So probability x being 0 will be basically you need to just sum all of these values, right? Yeah, sum of the first row. So which means 1 by 6 plus 1 by 4 plus 1 by 8. Right? You can say this is a marginalization because you are basically marginalizing over all the values of y, which means you have the joint probability distribution. You don't have the marginalized distribution. So this is called marginal distribution. Okay. Anyway, the names are not important, but you don't have the marginal distribution. You have the joint probability distribution. Probability of x being 0 is basically probability of x being 0, y being 1 plus probability of x being 0, y being 2 plus probability of x being 0, sorry, y 0, 1, 2, right? Y being 0, y being 1, and y being 2. Right? So that's how you can calculate the probability. We can say by is getting marginalized. So I don't know why these kind of questions are being asked, like who is getting marginalized, or I don't understand the context of this. Like I have seen these kind of questions in the group also, that what is getting marginalized. It's not like, it's a process. This process is called marginalization. I mean, there is no particular thing that who is getting marginalized, what is getting marginalized, and all. So these kind of questions, according to me, doesn't make any sense. Okay, this process is called marginalization. Like whatever we are doing is called marginalization. Okay. So now you can just add all the probabilities. So which means this is the final answer. Now what is the probability of x being 1? Again, you can just add all the probabilities, 1 by 8 plus 1 by 6 plus 1 by 6, right? What is the probability that y being 0? Now again, you can just sum up all of these probabilities. I think you can find out, right? So it is basically 1 by 6 plus 1 by 8, something like this. So basically, what you did, you can find out this particular summation, and there will be some value here. You can find out this particular summation, there will be some value here. There will be some value here. If you find out this particular summation, there will be some value here. There will be some value here. So what is happening currently? Given the joint probability distribution, you are finding the individual probabilities, right? So given the joint probability, you are finding the PMF. PMF means probability mass function for a particular random variable, which is x. So what is the PMF of x? So this is the PMF of x, right? This is called PMF of x. PMF means, can anyone tell me PMF means what? Probability mass function means what? It is just listing down all the values of the probabilities for x. Okay. So if x can take two values, then if you know both of the answers, then you will say that you have the PMF of x. Is this fine to everyone? I mean, we will see it formally later, because when we start the discrete random variable, at that time we will see it. Okay. So currently, like I'm just telling you the loose definition, which is basically I'm saying that this is again the PMF of y, probability mass function. Okay. So basically it is just listing down all the values of probabilities where like, oh, I mean, whatever value y can take, you need to list down all the probabilities. Okay. So this is the PMF of x, this is the PMF of y. Yes, you need to study both discrete and continuous. Actually, those discrete and continuous, this will take just, I think, 1.5 hours or maybe 2 hours. I mean, this will not take much time. But only thing is that you have to understand the basics. Okay, here you just have to understand the basics. Cool. Now I think you can do it. Now let's just see if we can find out this. What is this? This is conditional distribution, right? Or the conditional probability. So this is the probability of y being 1 given that x being 0. Let's just see if you can find out this. What is given here? You are given with joint distribution, right? So you are given with the joint distribution, and then they are asking individual distribution. They are asking the conditional distribution. They are asking many things given the joint distribution, right? So the joint distribution is given to you. Remember, okay? So let's just find out this. Now, what do you think? Like, can you just do it? Maybe okay. Like actually, it is not recommended, but can you just do it with intuition? Actually, in probability, I'm not recommending you to use the intuition, but still, x equal to 0 means just forget about it, right? Okay, and these are the probabilities that you have. Now, is this good enough? I mean, can I say that this is the valid probability distribution? Can I say no, right? I cannot say that this is a valid probability distribution. So you need to divide with, yeah, you need to normalize it. Yes, away. That is right. You need to divide with the number, which is 1 by 6 divided by 1 by 6 plus 1 by 4 plus 1 by 8. What is this number? Can anyone calculate? 13 by 24. Okay. So this number is 13 by 24. So you need to divide by 13 by 24. And then only you can say this is a valid probability distribution, right? Currently, it's not a valid probability distribution. So you will say that if you need to find out y equal to 1, then it is basically 1 by 4 divided by 13 by 24. Actually, वो formula ही, like finally you will be just having the formula only, but still, yeah, 4 by 13. Yes. Just a second. Okay. Okay. So this is, you can say using the intuition, but yeah, you can also apply the formula. So maybe using Okay, just give me 1 second. Okay, just give me 1 second. Yeah, sorry, it is 6 by 13, right? Cool. So I'm saying this is using the intuition, or maybe intuition, or what should I say, reduced domain, basically, right? Now I know that you have understood this particular method, but I still don't recommend it. Okay, because it is better to be safe in the exam. So what is the safe method? To use the formula directly, right? So the formula here is that probability of y being 1 given that x being 0 is basically nothing but probability of y being 1 comma x equal to 0 divided by probability of x equal to 0. So now probability of x equal to 0 is 13 by 24, and this probability is 1 by 4. So 1 by 4 divided by 13 by 24. Yeah. Anyway, the answer will be same. Everything is same, but still, like, just use the formula directly. So this is 6 by 13, right? Yeah. Cool. So what just happened? Like, they have given you some joint probability distribution, and they have asked you whatever they wanted to ask, which means they have asked you the individual probability distributions. They've asked you the conditional probability distribution, right? So they've asked you everything that they wanted to ask. Now, this is one last question, and let me just tell you this last question, and then I will tell you something interesting. So what they're saying, are X and Y independent? So what do you think? Are X and Y independent? Given this particular table, can you infer that X and Y independent or dependent, something like that? So let me go to the next page. कॉपी क्यों नहीं हो रहा? Okay, just tell me, are X and Y independent or not? If they're independent, then how you are saying they're independent? If they're not independent, then how you are saying they're not independent? This is the question that we want to ask, right? Cool. Let's just see the answer. So to calculate or to confirm that whether X and Y are independent or not, you have to check for all the values of X and Y, which means what you need to do, you need to check whether probability of X being 0, comma Y being 0 is same as probability of X being 0 multiplied by probability of Y being 0, right? You need to check for this. You need to also check for probability of X being 0, comma Y being 1 is the same as probability of X being 0 multiplied by probability of Y being 1. You need to check for all the possible values. There is no other way. Probability of X being 0, comma Y being 2 is the same as probability of X being 0, right? X being 0 multiplied by probability of Y being 2. So you know these probabilities are given in the table, right? Now let's just verify. What is probability of X being 0, Y equal to 0? I think this is 1 by 6. What is this? This is 13 by 13 by 24. What is this? 1 by 6 plus 1 by 8. So 1 by 6 plus 1 by 8. What is this number? 8 plus 6, 14 divided by 48. So this is 7 divided by 24, right? This is 7 in multiplied by 7 divided by 24. Let me know if this is equal. I don't think this is equal, right? So since these two are not equal, since it is failing at like it either just to say that they are not independent, it has to fail at one of them. If it is not failing for any one of them, you will say they are independent. If it is okay, if it is failing here, then you will say they are dependent, right? So you will say x and y are dependent variable. Why? Because this is not equal to this. So that's why you will say that yes, one counter example is enough. You will say x and y are dependent variable. Okay. So what is happening here? Now they have given you, just check it. They have given you some probabilities, right? Which are the joint probabilities, and then they have asked you some other probabilities. They have asked you whatever they wanted to ask, which means they have asked you marginal probabilities, they ask you conditional probabilities, they ask you whether X and Y independent or not. So they ask you many different kind of questions. So that was possible just because they have given you the joint probability distribution. So see, this joint probability distribution is very powerful probability distribution that one can hope for. Okay. So see, let me just copy this. See, this is the joint probability distribution, right? Now, this joint probability distribution is so powerful that in machine learning, everyone is hoping for just joint probability distribution. So this is joint probability distribution, which is very powerful distribution. Okay, very powerful distribution. It is so powerful that it can answer any of the question, which means if you want, it can answer the probability of X equal to 0. How? You can just marginalize. If you want, you can just ask for any conditional probability or whatever type of probability that is coming to your mind, it can answer that kind of question. Is this okay to everyone? In machine learning, obviously you don't need to know it, but in machine learning, there is a field. Has anyone heard of generative models, GAN and all? Okay. So in machine learning, there is a field that is called generative models. In machine learning, there is a dedicated field that is called generative models. This generative models, yeah, discriminator and generator. Yes, this generative model is just based on only one thing. And what is that thing? They're trying to learn joint probability distribution. Trying to learn joint probability distribution. So they can generate any kind of data. Okay. If you know the joint probability distribution, you can generate any kind of data. So what do I mean by that? Like, for example, suppose you have a joint probability distribution of spam mails. Okay. Suppose you know this joint probability distribution for any mail, and then whether it is spam or not spam, something like this. You can calculate. Let's suppose for any mail, you can calculate this probability or this probability, whether this is spam or not spam. Let's suppose for a particular mail, this is mail 1. Okay. For a particular mail, this probability is 0.1, this probability is, let's suppose, 0.9. Okay. I mean, need not to be 0.9. It could be, need not to be like, some need not to be basically 1 here, I think. No, some has to be 1, right? Some has to be 1. So yeah, some has to be 1. So it is 0.9. Okay. So this is, let's suppose, 0.1, and this is, let's suppose, 0.9. Then what will you say about this particular mail, whether it is spam or not? Whether it is spam or not spam, right? Why? Because this particular mail is basically, I mean, most probably it is not spam. Basically, like, generally we need to also calculate the conditional probability. So what is happening here? Like, what we can do? Let me just tell you. Okay, I will come to this question later. What we can do? How sum is 1? Because spam and not spam are the only two possibilities, right? Sorry, sum has to be the probability of mail. Okay, sum has to be the probability of mail. Yeah, so mail 1. Yeah, sum need not to be 1. No, okay, sum need not to be 1. Yeah, sorry about it. So what I wanted to tell you is that let's suppose that you have a mail that is having some words, which is, let's suppose, congratulations, you won lottery. Okay, this is your mail. Suppose this is your mail. And then you want to check whether this mail is spam or not. Then what you will do? You will do one thing, that given that this is a mail, okay, you will calculate these two probabilities. Given that you have some mail, and then you will check whether it is spam. So you will check these two probabilities. Which one is higher, right? Or not spam? Given that it is a mail, whether it is spam or not spam. Which one is higher? If this is higher, you will say it is a spam. If this is higher, you will say it is not a spam, right? So that's what you can do. Why? Because you have the joint probability distribution. If you have the joint probability distribution, then can you check whether some mail is spam or not? Can you calculate these conditional probabilities if you have the joint probability distribution? You can calculate, right? If you have the joint probability distribution, you can calculate the conditional probabilities. That's okay. But joint probability distribution is not that limited, which means you you are not that much restricted to only check the probabilities. It can do wonders. Let me just tell you what it can do. So what you can do, since you have the joint probability distribution, what does this mean? For any possible mail, you can basically put that mail here, and then you have this probability, which means mail and comma spam, mail comma not spam. You have this probability, right? So for any possible mail, you have some probabilities. Now what you will be doing, let's suppose you want to generate the data. Okay, suppose we want to generate spam mails. Okay, we want to generate or not spam mails or something. I mean we want to generate data basically, right? So we want to generate data. Essentially we want to generate some data. Now what you can do, you can just do one thing. You can just say something like this: spam, and then probability of that mail not spam. Now what you will do, you will try putting it some values, some mail here. Okay, some random words. Okay, some random words you will be doing it. Obviously there are methods, but let's suppose you put some random words here. Okay, and then you put the same random words here. Then suppose that this probability is coming greater. Sorry, whatever. So this mail is here. Just a second. Actually, it is obviously not relevant, but I'm just telling you that this joint probability distribution is very, very helpful. Suppose this mail is here. Given the mail, okay, given the mail, you want to check whether it is spam or not spam. So what you will do, you will put some random words here, right? Some random words. Now you will check, okay, I have put some random words, and let's suppose after putting that random words, you have found out that this probability is very, very high, maybe 0.8. Okay, let's suppose this probability is 0.8. In that case, you will say, obviously this probability will be 0.2 then, because the summation is 1, right? Yeah, the summation should be 1. So you will say that, okay, this probability is very good. Then by these random words, with these random words, you will be sure that this mail is spam, isn't it? Given these random words, you are saying that, okay, this mail is spam. So what is happening here, that you have just put some random words, and since you have the joint probability distribution, you can calculate this probability, right? You can calculate this probability, and then you are saying that, okay, finally I found a mail which is very likely to be spam, so I can generate spam mails, isn't it? So basically, given the joint probability distribution, you can even generate the data. That's the thing. And there are models like generative models which are just working on the same way. Okay, in machine learning, obviously, like here we don't need to discuss it, but in machine learning there are a special field that is called generative models, which are just doing one thing. They're trying to learn the joint probability distribution, because joint probability distribution is very powerful. If you have the joint probability distribution, even you can generate the data. Okay, you can not only check the data given the mail, you can even generate the data, right? So which is very powerful. I mean, which is why these generative models are being popular nowadays. Okay, so let's move to the next question. So here in this question, I just wanted to solve these things, and just wanted to tell you that joint probability distribution is very powerful. Okay. By the way, this question is clear to everyone or not? I mean, whether you're convinced or not, whether joint probability distribution is powerful or not, is not much required, but this question is clear, right? This question should be clear. Okay. Now let's solve this question. What they are saying, I toss a coin twice and define a random variable x. You can define your own random variable. It's not an issue. So they have defining their own random variable x to be a number of heads I observe. Okay. So what are the possibilities? Maybe head, tail, head, tail, right? What is JPP? Himanshu saying is by default the JPP has to be dependent. JPP, joint probability. Okay, joint probability distribution. Dependent means no, it is not default or something. No, it is not default. I mean, here it is coming out to be that they are dependent, but it is not default. You need to check it. Okay, you don't know. Okay. Now, suppose they are saying that you're tossing a coin twice. If you're tossing a coin twice, then these are the four possibilities. Now they are saying you're defining a random variable x, which is number of heads observed. Now tell me what is the value of four. I mean, this sample space will get mapped to some value using this x. So to which value it will map to? Number of heads observed. This is 2, 1, I think 1 and 0, right? Then I toss coin two more that coin two more times. And then I define random variable y to be number of heads observed this time. Okay, so this is what I did, and now I'm just rolling. I'm just tossing out two more times. So then also I will be having the same sample space, and now I'm having some y, which is also the same thing, which is saying 2 1 1 0. But I'm tossing it four times, right? Two times for x, two times for y. Is this okay to everyone? Now they're asking this joint probability distribution, which is probability of x less than 2, comma, y greater than 1, which means end, comma means end. Why same? Because you're saying y is also defined in the same way. Y is to be number of heads that I observe this time. So number of heads, if you're defining it, I mean, if you're tossing it two times, the number of heads again here, like you will be having these four possibilities. So here just two and then the 1 1 0, right? No, sample space is fixed. Sample space is fixed. Sample space is this one only. H, something like this, right? I mean, one second. You're tossing it four times. Yeah, I don't think it will matter, but let me write it. Yeah, sample space will be fixed, which is you're tossing it four times, and here x is 2 and y is also 2, right? But for example, if we are having some other let's suppose outcome, which is, let's suppose HT. In that case, what is x? X is 2, and what is y? Y is 1, right? Y is 1. So yeah, you can have this kind of I mean, this will be the only sample space that we will be having. So yeah, this is right. No, number of heads this time. This time means I mean, the language might be confusing, but this time means that number of heads in the last two tosses. Okay. This time means here, I mean that number of heads in the last two tosses. Okay. So here y is defined like that. Like since I have typed this question, so I know what I meant. So this time means the last two tosses only. What is the use of tossing it again? Like, okay, you are saying what is the use of tossing it again? What is the use of tossing it at the first time? What is the use of tossing it at the first time? There is no use. It is just a question. I mean, they are just having some experiment, right? So they are doing some experiment, and then they want to calculate something. Now they are asking it that what is the probability that x is less than 2 and y is 1? Y is greater than 1. Cool. So x less than 2 means what are the instances? So okay, first tell me, can I just factor it something like this, x less than 2 into probability of y greater than 1? Are these independent random variables? Does it depend then that what has happened in these two tosses, will it affect that what will happen in next two tosses? No, right? So these are the independent toss, obviously. So that's why it will not matter. So that's why you can factor it out. Why? Because here x is basically dependent on first two tosses, y is dependent on last two tosses, and there is no relation. Like the first two tosses cannot impact the last two tosses. Okay, so you can just factor it out because these are the independent random variables. Now tell me what is the probability that x is less than 2? X is less than 2 whenever you have zero tosses or one tosses, right? So zero heads or one head. So maybe all tails in the first two, all first two maybe like both tails, and one toss, right? So HT or TH. Yeah, I think there are there are only three possibilities with respect to first two tosses. But yeah, here, if you want this kind of sample space, so here you have how many possibilities? Every possibility is having four more possibilities, right? Four. How? This is not just TT. This is, can anyone tell me? This is TTHH. This is TTHT. This is TTHTH. This is TTTT, right? So basically, every possibility is having four other possibilities associated with that. So anyway, like if you want, I don't think it will matter. If you want, you can work with just these two possibilities. I mean, just like that, because it will be identically, I mean, this is very much symmetric. So anyway, here, let me just work with this sample space. So tell me what is the probability of these three. Out of 16, how many possibilities you have? 12 possibilities, right? Where x is less than 2. 12 possibilities where x is less than 2 out of 16. So you will say 12 by 16, which is 3 by 4, right? Which is 3 by 4. So here you will be having 3 by 4 into y is greater than 1. Y greater than 1 means that you will be having 2 exactly equal to 2. So HH. So this is the four possibilities. Out of 16 you have four possibilities, which is 1 by 4. So that's how you can calculate this, right? Yeah, that's what I'm saying. You can directly write 3 by 4 also. That's not an issue. Or if you want, you can directly, I mean, if you don't want to write it directly, if you are confused, then you can work with the complete sample space like that. Okay, because things are very much symmetric, so you can write it directly also. So finally, the answer will be 3 by 16. So what is happening here? The only observation we did is that x less than 2 and y greater than 1. So there are two random variables x and y, both are independent. So you can just factor it out and then you can calculate the probabilities. So that was easy question only. Let me know if there is any doubt here. Okay. Now let's solve this question. In this question also, they are saying that given the joint probability distribution, so they have again gave you the joint probability distribution. Find the distribution of x and y. Okay, distribution of x and y means that you need to find the probability that x being 1, find the probability that x being 2. So I think you can just sum all of this, right? You can sum up and you can find out the probability for x being 1, for x being 2, x being 3, x being 4. Similarly, for y being 1, 2, 3, and 4. You can find out the column and summation of columns and summation of rows to find out the marginal probabilities. Now, let's just see this. Find out the probability of y being 1 given that x being 1. So it might be interesting. So let's just find it out. Probability of y being 1 given that x equal to 1. Again, just directly use the formula, or if you want, you can do one thing. You can say that, okay, given x equal to 1, so just forget all of this, and then probability of y being 1. Is this correct? 1 by 16 is the correct answer or not? No, right? We need to normalize it. So 1 by 16 divided by whatever is the normalization constant. So what is the normalization constant here? This is 1 by 16, 2 by 16, 4 by 30, sorry, 2 by 16, right? So which is 4 by 32, 5 by 32, right? So finally 5 by 32. You need to divide by 5 by 32. So that's how you can solve it. I think 2 by 5 is the answer, right? Okay. So I hope you can do it now. Right? Cool. So I think that is all for this particular question, because the same question we have already solved. Now let's solve a bit more interesting question. This is the question that I have taken from MIT. Okay, so there is one book, MIT book, and in that from that book, I'm just referring that book to solve our no, in this particular course, I'm referring that book only. So there is one MIT book that you don't need to refer, but if I have to take any screenshot or anything, so I just refer that book. Like all of these screenshots, these things, this question, this screenshot, everything is from that MIT book only. So this question I have taken from that MIT book. Again, let's just solve this question. This question is very interesting. Let's just solve this question. Right? So what they're saying, consider the following binary communication channel where you are communicating X and then you are getting Y. But in between, there is some error Z. I mean, there is some noise, not error, sorry. There is some noise Z, which is getting introduced. And then this Y is basically finally a function of X and Z, which is X XOR Z. Now they are saying that X and Z are independent, which means the noise that is getting introduced, it does not matter that what you are sending. It is independent noise, okay? Maybe based on the communication channel that you are having. Now they are saying find the probability of Y being 0. So the probability of X being 0 and Z being 0 is given to you. Let me just do one thing. Let me just copy it. So these two probabilities are given to you. And then they are saying Y is a random variable, which is a function of X and Z. Y is a random variable, which is a function of X and Z. Now what they are saying is that, can you calculate the probability of Y being 0? Let's suppose this is the first question that they're asking. We will be just having more variations of this particular problem, but let's just first solve it. So what to do here? This is same as saying probability of X XOR Z equal to 0. And X and Z are independent. So can you tell me when will X XOR Z will be 0? I think both are 0 or both are 1, right? So that is same as saying both are 0 or both are 1. Both are 0 is having some probability, which is P into epsilon. Why? Can anyone tell me why I am writing multiplication? Because these are independent. Yes, these are the independent. Because of the independent assumption, because it is given here that X and Z are independent. Because of that independent assumption, I'm just multiplying, right? Okay. So plus because of the independent, right? Plus 1 minus P into 1 minus epsilon. Why? Because X and Z can take just two values. And if X equal to 0 is having probability P, then X equal to 1 will be having 1 minus P probability. So that's how you can solve this question. I hope that is okay. Now, if you want, you can just draw the table also. So which means this is X, Z, this is Y. This is 0, 0, 0, 1, 1, 0, 1, 1. Now, what is the value of Y here? This will be, I think, 0, 1, 1, 0, right? This is correct, right? Okay. Now, if I just ask you, what is the probability that Y being 0? Then you will just sum up both of this. Why? See, just understand here that this X is 0 and Z is 0 having this particular row itself is having some probability, which is P into epsilon. Now tell me, is there any different probability for Y being 0? I mean, do you have to add something or multiply something or something like that? Y equal to 0, Y being 0 in this case is just a byproduct, which means automatically it will happen. There is no probability needed for that. See, whenever X is 0 and Z is 0, automatically Y is 0, right? So what is the probability of Y being 0? In this case, it can happen in two cases, in this case or in this case. So what are those probabilities? P into epsilon plus 1 minus P into 1 minus epsilon, right? Okay. Now let's just solve some more questions here. Suppose they are asking some conditional distribution. Given that X equal to 0, what is the probability of Y equal to 0? Suppose these kind of questions they are asking, right? Okay. Can you solve this question? Like the information which is given is this: probability of X equal to 0 is given to you. Probability of Z equal to 0 is given to you. This is P or epsilon. Okay. This is P. This is P. This is epsilon. And then Y is given to you, which is X or Z. This information is given to you. Using this information, can you solve this particular question? What is the answer you are getting? Okay. So let's just solve it. Probability of Y equal to 0, given that X equal to 0, right? Now, is the same as saying probability of X or Z equal to 0, given that X equal to 0. Now, you can just put the value of X equal to 0 here, and then it will be probability of 0 or Z equal to 0. And since you have put the value of X equal to 0, you don't need to write it again. So it is same as probability of Z equal to 0, right? Is this correct? Which is epsilon. Let me know. Actually, by coincidence, it is correct, but it need not to be like that. By coincidence, it might be correct. Yes, answer is correct, but the way is not correct. So what is incorrect here? I just skipped one step. See, you're putting the value of x equal to 0 here. It is okay. But you can't just remove this reduced sample space which is given that x equal to 0. You can't just lose this information, right? So you have to write it. So 0 George z equal to 0, given that x equal to 0, right? You have to write it. You're getting my point? So whenever you have any information, you can't just remove it by your choice. Can you show the question once? Okay. The question is this, that they have given you that y is x George z, and then they're just asking you the probability of y being 0 given that x being 0. Okay. So actually, what I have just shown is just a common mistake that people do, that you are just removing this given that x equal to 0, but it is not the case. Yes, right. Okay. So I think you can solve it, and then finally epsilon is the answer you are getting. So I think we have solved it using multiple methods, so I don't need to solve it again. Is this okay to everyone? You can solve these three questions, right? Remaining three questions. Sir, x and z are independent. Then probability of z given x. Yes, you're right. You're right. So probability of z given x is same as probability of x. Okay. Because these are independent. Okay, cool. Now you can calculate all of this, right? Because we have solved it multiple times. Now let's just solve one gate p by q. So this is the almost same question that they've asked, not the almost same question, because they have defined their own function of the random variable, but maybe we can solve this question also, right? So what they're saying, that suppose xi's are 1 to 3 are independent and identically distributed random variables. So actually this is a common term in probabilistic models. So independent and identically distributed, like people say it IDD, independent and identically distributed. It means that x1, x2, x3 are independent, and also identically distributed means that they are having the same probability, which means xi equal to 0 and xi equal to 1 is having the same probability, which is 1 by 2. Anyway, like, you don't need to know the actual meaning of this independent identically distributed, because they have given it, right? Identically distributed means that 0 and 1 is having the same probability. It is what identically distributed means. Independent means xi and xj are independent. Okay. Anyway, this is the common term. That's why I just told you this IDD is a common term. So they have given you that probability of x1 equal to 0 is same as probability of x1 equal to 1, and which is 1 by 2. Now, similarly, this is, these all the probabilities are same. In fact, the x2 equal to 0 and x2 equal to 1 is like all the probabilities are same, which all the probabilities are 1 by 2 only, right? All the probabilities are 1 by 2, which is given to us. Now they have defined a new random variable y. Let me go to the next page. So y is a new random variable, which is x1, x2, or x3, right? Now they are saying, can you calculate this probability? The probability of y being 0, given that x3 equal to 0. Okay. Just try it out if you can do it. And what is the information that is given to you? Probability of xi equal to 1 is same as probability of xi equal to 0, which is same as 1 by 2. Answer I don't know actually. 1 by 2 nahi hai, but answer is not 1 by 2. Which is, I think, the most probably answer is not 1 by 2. 3 by kuch aisa hai, 3 by 8 hai. I don't remember answer exactly. Okay. Just try it out and let me know what is the answer you are getting. Okay. Sakshi is getting 3 by 8. Abhay is getting 3 by 4. I don't remember the answer actually. So let's just solve it. So what you can do, you can put x3 equal to 0 directly here. Maybe this could be one of the method. X3 equal to 0, if you put it, this is x1, x2, or x3 equal to 0, given that x3 equal to 0, right? Which is same as probability of x1, x2, or x3 means, or 0 means you don't need to write it. So given that, okay, just tell me, is this okay to say something like this? not directly, I mean, like by coincidence it is happening, but by coincidence it may happen, but you can't directly write like this, right? I mean, now you know that okay, x1 x2 x3 are independent, so any function of x1 x2 is independent of x3 also. So now you can write like this, that's okay, right? Now you can write like this, that's okay. But you cannot directly write like this. I mean, you cannot directly say that okay, I have used this x3, now let me remove this x3. No, you can't do this. Okay, actually in every of the question it is happening that you can directly, I mean, you are arriving with this conclusion, but I want to make sure that this is not the general thing that we can do. You have to go through the process. Okay, you can't directly omit this x3 equal to 0 dependency. Cool. Nice point. नहीं तो मैं यही सोच रहा था. हाँ, cool. So now you can calculate this x1 x2 equal to 0. Maybe when can x1 x2 will be 0? Then both are, any one of them is 0, right? Any one of them is 0. So when the x1 is 0, x2 is 1 or something like that, right? So maybe let me go to the next page. Probability of x1 x2 equal to 0. This is same as probability of x1 equal to 0, comma x2 equal to 0 plus probability of x1 equal to 0, comma x2 equal to 1 plus probability of x1 equal to 1, comma x2 equal to 0. These are the three things. Now, what is the probability that x1 equal to 0 and x2 equal to also 0? Since these are independent, so you can say this is same as, this probability is same as 1 by 2 into 1 by 2, because these are independent. And x1 equal to 0 probability is given to us, which is 1 by 2, right? So this is 1 by 4 plus 1 by 4 plus 1 by 4. Why? Because see, this is actually 1 by 2 into 1 by 2 plus 1 by 2 into 1 by 2 plus 1 by 2 into 1 by 2, right? So that's why the final answer is 3 by 4. Okay. So that's how you can solve this question. This is very normal question. I mean, from now onwards, you should be comfortable with these kind of questions, right? Can anyone answer this question on the gate or flow? I'm not sure if the answer is good or not there. So if that's not very convincing, just write down a nice answer. If possible, write down all the different methods that we have seen. Maybe let's just revisit all the methods. So let's just say that this is method 1, right? Where we are putting the value, right? So maybe I can say this is just method 1. Just do one thing. See, whenever you have, let me just tell you a hack that how to be popular on Gate or Flow. Okay, so there is one hack which is that I have used in my preparation. I mean, I don't know that I am popular or not, but I have used that hack. Automatically, that happened actually. So whenever you have any chance on contributing some question on Gate or Flow, and that question is also Gate P by Q, then do it blindly. If that if we are contributing on the gate P by Q, you will be very, very popular very, very soon. Okay, because people see gate P by Qs more often than other questions. So if you are answering on the gate P by Q, then automatically, I mean, there will be more engagement there, right? So whenever you have gate P by Q, then just don't give a chance to leave that answer. So I mean, just answer it out. Okay, so cool. Now I hope that that is okay. Now let's just see if we can solve it using some other method also. Maybe I can call it method 2. I mean, these are not different methods. These are the same methods. It is just that I just want to let you know that yes, I mean, you can think in whatever way possible. Whatever is coming to your mind, you can just think in that way. Okay. Maybe I can make a table. If you are, let's suppose, very much particular about the table, let's just make a table. Okay, I just want to make sure that you have understood everything very clearly. That's why we are having different methods. Otherwise, I think this is just one or two. I mean, there is no different method. So Jor X3, okay, right? This is y 0 0 0 0 0 1 0 0, okay, 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. Okay, suppose this is the thing. Now Shakshi has written the value. I'm just writing it down. Maybe if this is incorrect, then just let me know. 0 1 0 1 0 1 1 0. Are these values correct? Okay, I'm hoping these are correct, right? So this is y that we are getting. Now, what we wanted to calculate, probability of y equal to 0 given that x equal to 0, right? Yeah, x3 equal to 0. Cool. Maybe I can work with the reduced sample space. So x3 equal to 0 means maybe I can just omit all the things. X3 equal to 1 I can omit, right? X3 equal to 1 I can omit. Now tell me, what is this probability? 1 by 2 into 1 by 2 into 1 by 8, 1 by 8, right? Is this correct? This is also 1 by 8. This is also 1 by 8. This is also 1 by 8. Are these probabilities correct? In the reduced domain, right? So obviously you need to normalize it because the summation is not 1. So 1 by 8, it is not actually 1 by 8. This is 1 by 8 divided by 1 by 2, right? 4 by 8. So multiplied by 2, I think. Yeah. So this will be 1 by 4. And I think everything is equally likely. So I think you can directly write 1 by 4, 1 by 4, right? So everything is 1 by 4. Now they are asking about this y equal to 0 probability. So you can just sum up all this. Then you will be getting 3 by 4. So finally, you are saying 1 by 4 plus 1 by 4 plus 1 by 4. So whenever you are working with the reduced domain, you have to normalize it again. Otherwise there will be a problem. Okay. अब I saying wow. इतना भी wow moment नहीं था, but ठीक है. मतलब if you are appreciating, it is good. So have you understood that? That if you are having any reduced domain, then you can't directly write the probabilities. Okay. I mean, ये 1 by 8 को बस change करना. Don't forget from here to here. Otherwise the question will be wrong. ठीक है. Now maybe we can see some other method also. Let's just see if tree is making some sense. Okay, so let's just see method. I mean, actually, to be honest, these are not different methods or something. I just want to make sure that whatever interpretation you are doing in the exam, everything should be correct. Okay, so let's just say that it is method 3. So method 2 is basically reduced domain, right? Now, maybe I can make a tree. Okay, tell me, should I be starting with x1? I mean, x1 being 0 or 1 or something like that? Or I should be starting with x2 or x3? Any recommendation? X1 being 1 or something? Since these are symmetric, right? I mean, doesn't matter x1, x2, x3. These things, these. I mean, I don't think there is any difference between x1, x2, x3. These things seem very much symmetric. So let me just start with x1. So x1 may be 0, x1 may be 1, right? Now, what are the probabilities? This is 1 by 2. This is 1 by 2, right? Okay. Now, here, x2, let me just at this level, let me just write x2. x2 may be 1, x2 may be 0, x2 may be 1, x2 may be 0, x2 may be 1, right? And again, at the last level, let me write x3. x3 may be 0, x3 may be 1. x3 से चालू कर देना तो शायद ज्यादा थोड़ा ठीक रहता. नहीं, given that x3 equal to 1 था ना, तो like I could have just removed one of the branch, maybe. Okay. So let me start with x3 because I will be just removing one of the branch in that case. This is x2, right? Okay. I thought it is 1 by 2. Okay. Now this is like okay. Let's have that as method 4. So Himanshu is saying कि x1 को सबसे पहले लिखना है. We can have it as a method 4. Okay. Let me first do it. x1. So now you are saying x3 equal to 0 is given to us, right? Which means that you can just remove one of the branch completely. Which means you can say that here you can just remove one of the branch completely. And now they are asking the probabilities. Now tell me, what is the probability of y being 0? So y is 0 whenever, this is x1, right? x1 is 1. Whenever 0, 0, 0, 0, 0, 0, 1 and 1, 0. Okay. 0, 0, 0. I think एक ही केस में है ना, जब x1 x2 दोनों 1 है. In that case only, right? x1 x2 both are 1. In that case y is 1. Otherwise in this case y is 0. In this case y is 0. In this case also y is 0. Now tell me, what are the probabilities here? Okay, tell me, my voice is low or my voice is fine? Is this low? Okay, fine. I know that Deepak voice might be greater because he's okay low in the videos. Okay, I will just fix it, but I don't know why it is low. I mean the placement of this mic and camera, everything is like that only in the videos also. Okay, it is actually concerning. I will just check it. Okay, so I will just check it. What is the problem? Okay, so now now if you just ask me what is the probability of y being 0, then it will be these three branches, right? I mean, you just need to add these three nodes, which is 1 by 4 plus 1 by 4 plus 1 by 4, right? Which is 3 by 4. Let me know if that is okay. Okay, so is this fine to everyone? Now, what if you start with maybe x1? Okay, maybe you can start with x1 also. Let me just say, I mean, actually, these are honestly like these are not different methods, but yeah, still, let's just start with x1. Maybe x1 is 0 or x1 is 1, right? Earlier, whatever we have said. So x1 equal to 0, maybe x1 is 1. Now, I think इसमें थोड़ा कॉम्प्लिकेट सा लग रहा है, but ठीक है. Okay, I think we need to apply the base theorem and all, because this is like a backward reasoning, right? I mean, given that this x3 equal to 0, they are asking that what is the probability of y being 0. Okay, so maybe I don't think that this particular tree might be useful directly here, because they are asking probability of y being 0 given that x3 equal to 0. I think we need to apply the formula only. So maybe let's just apply the formula. So which means that probability of y being 0, comma x3 equal to 0 divided by probability of x3 equal to 0. So let's just solve for this. What is the probability of y being 0? Sir, can you explain it using JOR operation without using x3 equal to 0 directly? Yeah, that's what we are doing. Okay, so currently that's what we are doing. So comma x3 equal to 0 divided by probability of x3 equal to 0. Now this y equal to 0 means same as saying probability of x1 x2 JOR x3 equal to 0 comma x3 equal to 0 divided by probability of x3 equal to 0. Okay, now tell me, can I separate these two, this term and this term? Are these independent? No, right? Because x3 itself is here, right? So these are not independent. So you can't directly separate it out. Here also you can't directly separate it out because y is a function of x3. How you can separate it out? But you can put the value which is x3 equal to 0. So now it will be probability of x1 x2 equal to 0 comma x3 equal to 0 divided by probability of x3 equal to 0. Now you can separate it out, and then you will be having probability of x1 x2 equal to 0, right? I mean, into probability of x3 equal to 0, but that will just cancel out. Which will just cancel out, which is actually equal to x1 x2 equal to 0. Right? So finally, x1 x2 equal to 0 that we have already seen, that is 3 by 4. So 3 by 4 is the correct answer here, right? Okay. I think that's the only possibility. Using that, we can solve this kind of question. Let me just think about it. If we have some other method also. Okay. So let's just solve this particular question using without using reduced domain, but using the table only. Okay. Now we will not be having the reduced domain, but we will be having the table. So let's have this table, but this time I will not go for the reduced domain. This is 0, 0, 1, 1. This is 0, 1, 1, 1. This is 1, 0, 1, 1. This is 1, 1, 1, and 0. Okay. Now, what I want to calculate, probability of y equal to 0, given that x3 equal to 0, right? Okay. Every of this node is having 1 by 8 probability, right? I want these probabilities by equal to 0, given that x3 equal to 0. Okay. So what I can do here, probability of y equal to 0, comma x3 equal to 0, divide by probability of x3 equal to 0. Now I will not put the values of, y value. I will not write this as x1, x2, or x3. I will not write it like this. So let me just see that how many tuples or how many rows are satisfying this particular thing. So tell me how many rows are satisfying here. Wherever y is 0 and x3 is 0. So I think this particular one, this particular one, this particular one, right? So 3 are satisfying. So what is the probability here? Can you tell me by looking at this table? 3 by 8, right? Because 3 are satisfying, so you know 3 by 8 is the probability. What is the probability that x3 equal to 0? I think that is given to you, which is 1 by 2, right? So that is equal to 3 by 4 again. I mean, it depends like how you are solving. So these all are the same thing. It is up to you, your understanding that how you are doing. So if you are making a table, you are not going for the reduced domain and all, then you just see that how many tuples are satisfying this particular thing. Okay. Okay. Just for the flex, I can say that, okay, this is method 5. So that if you just go to if any other person from any other coaching center will see this, then they will say that, oh, 5 methods just for one question, so it will look good, right? So it is a good promotion for Go classes. So that's why I'm writing it method 5. Otherwise all are the same things. Yeah. So you can understand in any way. Cool. So have you understood this particular method? So what we are saying here is that you are writing it in that way, and then you are just counting that how many tuples are satisfying this particular thing, right? And since 3 tuples are satisfying, so 3 by 8 is the probability for this, and then divided by this probability is given to us, which is 1 by 2. Let me just think if there is any other possibility that you can think of, maybe another method to solve this question. कुछ दिमाग में आ रहा है क्या? I think, yeah. Whatever actually you're thinking should be logically correct. That's my point. Okay. Whatever you're thinking, whatever way you are, that is coming to your mind should be logically very much correct. You should be confident about it. That's my only point. Okay. So Himanshu is saying that some question where putting x3 equal to 0. They are dependent variables. I think that's what you want to say. Yeah. So it might be in the test series, or I can just cover here also. So x3 in middle, that is unnecessary variation. If you want to put x3 in the middle, let me just think about it. Given that x3 equal to 0, I don't think that tree method will work there, right? Given that x3 equal to 0, directly tree method won't be working there. Cool. So anyway, I hope you have understood this particular question. So just answer this particular question if possible using all the different methods. I'm sure that within just 3-4 months or within just 6 months, your answer will be having more than 100 upvotes if you just answer this nicely. Okay, so just answer this very nicely. Just put it on gate or flow. Just have different methods, and if possible, then you can also solve some different variation of the same question, and then like your answer will be very much popular. I mean, I want to do all of this, but obviously, like due to the time restriction, I cannot do it. So one of you can do it, right? नहीं, लास्ट में क्रेडिट गो क्लासेस लिख देना. सचिन सर लिखने की जरूरत नहीं है. यू जस्ट राइट गो क्लासेस, दैट इज एनफ. if you want, otherwise नहीं, मतलब that won't look good. You just answer that question, that is only the priority. Okay, so today I just wanted to have one short class, which is I think short तो क्या मतलब, हाँ 1 hour हो गया ना, almost 1 hour 1 hour 15 minutes. So I just wanted to discuss few of these questions. Now let me just tell you that what is going to cover, like what I'm going to cover next. So what we are going to cover is basically expectation, which is very much important for the gate. And inside the expectation, I will be covering many interesting things. So the crux of this second chapter, which is random variable, here like, you will see in the expectation only. So I will cover many interesting things in the expectation, especially the difference between the expectation and the average. Expectation versus average, like what is the difference between expectation and average, like because these are the two commonly used interchange terms. Okay, and recursively finding the expectation, understanding expectation with very much depth. So we will be covering that. And then after this expectation, so expectation is a major topic which is remaining. After this expectation, whatever is the remaining is basically the topic name, but it is very small topic. So the discrete random variable, these are the definitions. We will be covering it, but it won't take much time. And continuous random variable. Okay, so thank you everyone. Let's just I will today I will try to record the expectation only. Okay, so midnight I will try to recording the expectation. Yes, distributions are there in the gate. So these two are in the gate. Obviously, like whatever we are studying, these are the things in the gate. Otherwise, we won't be studying. Okay, so thank you so much. Cool. So maybe tomorrow Deepak will be taking the class, and day after tomorrow I will be taking class. Okay, and this Wednesday, I think this Sunday is first order logic quiz, as Deepak has announced, and then I think Deepak is saying that 2 quizzes will be there for first order logic, right? If I'm correct. And then this Wednesday most probably we will be having one quiz for this probability. I will try to finish the probability before the Wednesday, and then we can have one quiz for the Wednesday, one complete probability quiz for the Wednesday. Okay. So thank you everyone. Take care. Bye bye.